Good day. In the next few lessons, I would like to discuss with you the grade 12 inverse functions. All the problems that I'm going to discuss within these lessons are from this grade 12 Mind Action Series textbook. We are going to discuss the inverse of the linear function, that is the straight line. Also, the inverse of the quadratic function or the parabola. And thirdly, we're also going to look at the inverse of the exponential function. In the first example, we're going to focus on the inverse of the linear function. So let's look at this first problem. As you can see in this first problem, they ask us to determine, and this notation, this f with an exponent of -1, that is the notation that refers to the inverse of f. So this question say, determine the inverse of f if fx is equal to 2x plus 1. And as you can see, this is a straight line graph. Now, whenever we find an inverse, the important thing is that we swap x and y. So that means x becomes y and y becomes x. So that is what we're going to do with this equation. So we say for f, and we write it now as y equal to 2x plus 1 because we need to swap. And then we say for the inverse of f, we get that x is equal to 2y plus 1. And as you can see, we swapped the y, this y with x and that x with y. And now you need to do manipulation and write this in terms of y. So we can now say that 2y is equal to x minus 1. And then we divide both sides by 2. So we get y is equal to x minus 1 over 2. Just to answer our question, we're now going to say that the inverse function of f is equal to x minus 1 over 2. So as you can see, the inverse of a straight line graph is fairly simple. A straight line graph is a function, and the inverse is also a function. And this is now the inverse of f. So that is function f, and that is the inverse. In the next example, we have a function fx equal to minus 3x plus 3. And then the first part of this question, they ask us to determine the equation of the inverse of f. And you can see we use that notation again. We're going to apply the same principle, and that is to swap x and y. So let's say now for f, and we write it always as y before we swap, is minus 3x plus 3. And then we say for the inverse, because that is our f function, when we find the inverse, we substitute y with x and x with y. And then it's just a matter of manipulation here. So we're going to say 3y is equal to minus x plus 3. And then we can find y equal to minus x plus 3 over 3. And now just to write down our final answer, they ask us to find the inverse of f. So we say the inverse function of f is then minus x plus 3 over 3. And you can see that is pretty straightforward. Let's now look at the B part of this question. In B, they ask us to sketch the graphs of f and the inverse of f on the same set of axes and show the line of symmetry. So we will still discuss this whole thing about the line of symmetry. But they ask us to sketch the graph of f and the inverse on the same set of axes. So what we're going to do is we're going to look at our straight line graph, which is y equal to minus 3x plus 3. And we're going to calculate the x and y intercept. So I'm going to say here, that for f, because I'm working with f here, I'm going to find the x-intercept. And that means that minus 3x plus 3 will be equal to 0. So therefore, minus 3x is equal to negative 3. So therefore, x is equal to 1. And then also for f, we're going to find the y-intercept because we want to draw this graph. And that is where we substitute x with 0, and we will get an answer of y equal to 3. Now, we want to find the x and y intercepts of the inverse function. Now, this is quite easy once you've got the x and y intercept of the function, because remember with inverse, we interchange x and y. So x becomes y, y becomes x. So that means the x-intercept becomes the y-intercept in the inverse, and the y-intercept becomes the x-intercept. So if I want the x-intercept of the inverse, that will be the same as the y-intercept of the function. But now it's just x, so we can just say x is equal to 3. If you want to, you can calculate it again, but it's not necessary. So then we find the y-intercept as well. And this y-intercept of the inverse will be the x-intercept of the function f. So we can say that y is equal to 1. So as you can see, the x and y swapped around whenever we are working with inverse. We're now going to plot these points on our grid. So for f, we're going to say that x is equal to 1. That is the x-intercept. And the y-intercept is at y equal to 3. And we're going to draw our line through those 2 points. I'm also going to plot the points for the inverse. The x-intercept is at 3, right here. And the y-intercept is at y equal to 1. And we're going to draw that line as well. So let's just draw those 2 lines. So as you can see now, we have the 2 lines. This one, function f, where the x-intercept is at 1 and the y-intercept at 3. And then the inverse function right here, and the y-intercept at 1 and the x-intercept at 3. Also remember to label your functions, that this f minus to the minus 1, that refers to the inverse function of f, and this one is called f. They also ask us to show the line of symmetry. Now, the line of symmetry is the line y equal to x. And the reason why is because we swap x and y with inverse. So when we refer to inverse, it's exactly the same as to find the reflection in the line y equal to x. And that line will go right through the origin. It will intersect right where the 2 lines intersect, and it will go up here. And that is our line of symmetry, and the equation of that line is y equal to x. So let's just draw that line. So as you can see, there is my line of symmetry. We always draw it as a dotted line. And please remember to put the equation on this line. And the equation of this line is y equal to x. That is always the line of symmetry when we deal with inverse functions. So there we sketch the function f with its inverse on the same set of axes. In part C, they ask us to determine the coordinates of the point of intersection between f and the inverse. Now, as you can see, that point of intersection is right there. That's where the two lines intersect. But also important, the line of symmetry, y equal to x, also intersect at the same point. So that means we're going to use simultaneous equations here, but we don't need to use the two straight lines. We can use the straight line given to us, and we use, that is now function f. So we're going to use function f, which was minus 3x plus 3, and we're going to solve it simultaneously with y equal to x, because as you can see, like I indicated, that this y equal to x also intersect at the same point. So you can either solve f and the inverse simultaneously, or you can use f and y equal to x, or you can use the inverse and y equal to x. I prefer to use function f with y equal to x and solve them simultaneously. So we're going to solve them now simultaneously. So we're going to say that minus 3x plus 3 is equal to x. And that means that minus 3x minus x is equal to negative 3. So that means that minus 4x is equal to negative 3. So that means that x is equal to 3 over 4. And because one of our functions is y equal to x, and you can see why I prefer to use it, because once you solve x, you know automatically what y is, because y and x are the same. So we can just say that y is also 3 over 4. So we can now just say that this point of intersection is the point x equal to 3/4 and y equal to 3 over 4. So that is the point of intersection right here. And you can see it corresponds more or less with our drawing. If that is 1, that is 3/4, and that is also 3/4, because x and y are the same at the point where they intersect. Thank you.